Hey guys, so moving on with the 7th video of our playlist electrochemistry. In this video, we will understand what is conductance, conductivity, resistivity, and in the end, we will do a relation between conductivity and resistivity. So let's start off with the video. So according to Ohm's law, what is Ohm's law? Ohm's law states nothing but R is equals to V upon I, where your R is nothing but your resistance, and what is the unit of resistance is nothing but ohms, right? Now, what is the basic definition of resistance? Resistance is nothing but the obstruction offered by the conductor to the flow of electricity. So in short, it is not allowing the electricity to pass through it, whereas conductance is exactly the opposite of resistance. Conductance is nothing but the how freely the electricity can move through a conductor. So over here, conductance is nothing but how good it is allowing the electricity to pass through it. So since conductance is exactly opposite to the resistance, Siemens derived a formula for conductance as 1 upon R. So G, which is conductance, is equals to 1 upon R over here. And unit was named after Siemens of conductance. And this Siemens is dimensionally represented as ohm raised to minus 1. Why ohm raised to minus 1? Because conductance G is equals to 1 upon R. So when we write 1 upon ohms, and when the ohm goes in the numerator, it becomes ohm raised to minus 1. This unit Siemens is also known as MHO, just reverse of ohm, OHM, and it is reversed and MHO. Okay, moving ahead, we need to understand on what factor does the resistance of a conductor is judged. So the resistance of the conductor is basically judged on two main factors. One, which is the length of the conductor, L over here, and A, which is the cross-sectional area of the conductor. Now, if the length of the conductor is greater, it is obvious that since the length is greater, the conductor will be able to apply more resistance to the flow of electricity. So since the length is greater, the resistance increases. Therefore, R is directly proportional to L. Now what is A? A is the cross-sectional area of the conductor. What is the cross-sectional area? Cross-sectional area is nothing but a diameter of the conductor. We all know the diameter. If the diameter of the conductor is greater, the conductor won't be able to apply more resistance because the electricity will now gain a greater path to flow through it. And since the obstruction offered by the conductor will be reduced, due to this, R is inversely proportional to A. Now if we want to replace this proportionality sign with the equal to sign, we have to put a constant over here, and a constant which we put over here is known as resistivity. How will you define resistivity? For defining resistivity, as usual, you have to put length as 1 meter and area as 1 meter cube. So when you put this as 1, automatically resistance will become equals to resistivity. So how will you define resistivity is that resistivity is nothing but the resistance offered by 1 meter length of conductor having 1 meter cube of cross-sectional area. So this was the definition of resistivity. Now what is the difference between resistance and resistivity? The resistance is nothing but the total resistance provided by the whole conductor, whereas resistivity is nothing but the resistance provided by 1 meter of conductor having 1 meter cube of cross-sectional area. So this is the basic definition of resistance and resistivity. Moving ahead, we need to understand what is conductivity. So as we all know, G is equals to 1 upon R. And what is the formula for R which we have got? R is directly proportional to length and inversely proportional to A. The similar condition is going to apply over here. Since G is the inverse of R, therefore over here we will get an inverse of this, which is 1 upon L. And again, if you want to substitute this proportionality sign with the equal to sign, you have to put a constant over here. And the constant which you put over here is K. And this K is known as conductivity. Now how will you define conductivity? Since you want to define conductivity with respect to conductance, you have to put all other parameters as 1. So you put area, cross-sectional area as 1 meter cube and length as 1 meter. So now G will become equals to K. So K is nothing but the conductance offered by 1 meter cube of conductor length 1 meter. So this is the definition of conductivity. So we have understood what is conductance, conductivity, resistivity and resistance. I forgot to mention the difference between conductance and conductivity. Conductance is the total conductance offered by the total conductor, whereas conductivity is the conductance offered by only 1 meter cube of diameter, cross-sectional area having 1 meter length. Okay, so over here K is just a multiplication factor, therefore it is always a constant. Now moving ahead to understand the relation between conductivity and resistivity. So from this formula which we have got, I just get a K over here. So K is equals to GL upon A. What is the value of G? Is nothing but G is the inverse of R. So just substituting the value of G as 1 upon R, we get K is equals to L upon R into A. Now what is the value of R which you have got over here? Rho into L upon A. Substituting the value of R in this equation, this L upon A I have written as it is over here, and this R I have substituted as A upon rho into L. This L and this L gets cancelled away, and this A and A gets cancelled away, and we have got the relation between conductivity and resistivity as conductivity is again equals to 1 upon resistivity. So we have got conductance is equals to 1 upon resistance, and we have also got conductivity is equals to 1 upon resistivity. So guys, important thing, don't forget to subscribe to the channel, because over here you will find all the videos regarding to 11th, 12th science as well as engineering, physics and chemistry. So guys, do subscribe to the channel and do like this video and do share it with your friends.